Hello, and welcome to section 1.5. A short section deals with properties of real numbers. Super fun. It's just basically talking about something that you might already know or intuitively know when you use these properties, but we don't usually say them out loud, if that makes sense. So here we are saying them out loud, giving them names. So very exciting. Okay, first of all, for any real numbers, we have what's called the commutative property of addition and multiplication. Have you ever noticed that it doesn't really matter what order you add things together because the sum ends up the same? Well, that's an example of the commutative property. So for example, you have 2 plus 3, that's 5. 3 plus 2, also 5. 1 plus 7, 8. 7 plus 1, also 8. Okay, this also holds true for multiplication. 2 times 3 is 6. 3 times 2, also 6. So when you're multiplying or adding real numbers, changing the order, it does not affect the result. Okay, the next thing that you may have noticed before is the associative property. You can regroup numbers when you're multiplying or add them, and you get the same result. So let's do an example. Let's say you have 1 plus 4 plus 3. Let's say if you group these two first, you would get 5 plus 3, which is 8. Interesting. Same situation, except for now, let's add these two together first. So you would get 1 plus 7, which is also 8. So you notice that associative has to do with regrouping, and then commutative is changing the order. So commutativity, I guess, it has to deal with the order, changing the order. Okay, so associativity also works with multiplication. Suppose you have 2 times 3 times 5. Let's say if I group these two together, that would be 6 times 5, which is 30. What if I group the last two together? So that would be 2 times, and 3 times 5 is 15 today. 2 times 15 is 30. Okay, so proof that they work. Let's do some more super fun examples. So let's say here you have 18p plus 6q plus 15p plus 5q. I can use commutative property, and some of these properties you can kind of just start doing them without even writing it out. Some people just, in your mind you can start doing it. But here's a very I switch these two, so then I group the two p terms together, so like terms. This becomes 32p. 6q plus 5q is 11q, and that's it. What about here? We can use associativity. You have 5 over 13, but we can regroup these, right? This will make it easier for us, right? 3/4 plus 1/4 is easier to add than 5/13. So that's going to be 5/13 plus, and then 3/4 plus 1/4 is 4/4, which is equal to 1, right? But we want to add common denominator. The common denominator is 13. What is the equivalent? Any number divided by itself is equivalent to 1, okay? So I can express 4/4 as 13 over 13, I mean. So really what I'm doing is 5/13 plus 13 over 13, which is 18 over 13, okay? Okay, here's another property, the identity property. When you're the identity property, you can think of it as it's an element or a number that does not affect, depending on what operation you're using, whether it's multiplication or addition, the identity element doesn't affect the original. So what am I saying? So let's say you have a number and you add 0 to it. That doesn't change the number. It doesn't add or subtract anything to it, so the value remains the same. So 0 is what we call the additive identity. Okay, so let's say if we have 8 plus 0, that equals 8, and it's commutative, so 0 plus 8 is also 8. In general, we use a, but it doesn't, and then for multiplication, 0 doesn't behave that way. It's 1 that is the identity, because any number times 1 will give me that same number back. Okay. 5 times 1 is 5. 1 times 5 is 5. Okay. Now the inverse is the number that you add to a different number to get you back to the identity. So the additive inverse is the opposite, okay? So if you have like 5 and you add the inverse, which is the additive inverse, which is -5, in other words, the opposite, you get back to the identity element under addition, which is 0. Okay, so additive inverses are basically just the opposites of the element. Okay, now multiplicative inverse, remember that under multiplication, the identity element is 1. So we already know what the multiplicative inverse, it's the reciprocal. Okay, so if you have, let's say 9, the reciprocal of 9 is 1 over 9. Okay, anytime you multiply through, this would be 9 over 9, we get 1. Okay, so for any number a, except for with the exception of 0, we can't divide by 0. So 0 does not have a multiplicative inverse. Yeah, so that's what that is. It's the reciprocal. And let's do some more examples with that. We can use the properties of inverses and commutative property to solve this problem here. So we have -84n plus 84n plus -73n. Now we can combine these two first, right? And these are additive, these are opposites. So the answer will be 0 plus -73n. Final answer is -73n. Okay, now let's look at this here. If we use commutative property, and we can write 7 over 15 times 15 over 7 times 8 over 23. These two are multiplicative inverses, right? Because they're reciprocals. So you would get 1 times 8 over 23. So then final answer, 1 times anything is still that anything. So this is 8 over 23. Okay, so let's do a couple of examples with 0. Okay, so imagine you have nothing and you split nothing up into many pieces. You will still get nothing. Okay, so that's the easiest way to describe that. If you have 0 divided by any term, or, you know, you will still have 0. Okay, that's for A. Now B, you cannot divide by 0. So this would be undefined. Okay, so we can never divide by 0. Okay, that's a mathematical no-no. Okay, finally, let's talk about distribution property. You can distribute from the left or the right of a sum or a difference. Okay, so when you multiply a sum or difference by a number, you can distribute it. Okay, so you can see here we're distributing from the left. Here we're distributing from the right. Here is distribution with a subtraction, right? And then here from the right, BA minus CA. So let's do an example here. 3 times the quantity x plus 4 becomes 3x plus 3 times 4. So that's 3x plus 12. Here we have the quantity, 8 times the quantity 3/8 x plus 1/4. So that becomes 8 times 3/8 x. Okay, that's 8 over 1, right? Plus 8 times 1/4. Again, we can write this as a fraction. Here, the 8's cancel. We get 3x plus, here, 8 over 4 is just 2, right? Because 8 divided by 4 is 2. So your final answer is 3x plus 2, okay? Let's do some more super fun examples of the distribution property. Remember, when you're multiplying by 100, you move the decimal place two spaces to the right. So here, this will be 30. 100 times 0.3 is 30, plus 100 times 0.25q would be 25q. How about here, -11? We also need to remember to distribute the negative. So -11 times 4 minus, so you could do -11 times 3a, which is the same thing here. This becomes a positive. This is -44 plus 33a. Okay, let's do some more examples here. When you have a negative immediately outside, you can distribute it. So that's -y minus 5. Done. Here we would, of course, do distribution first. We have 8. And then the -2 times x, -2x. -2 times +3 is -6. Combine like terms, 8 minus 6 is 2 today. And then what's left over is the -2x, right? Okay, so here we have a fun one. We use distribution property twice. So this becomes 4x minus 32, and then minus x minus 3 combining like terms, we have 4x minus x, that's 3x. We have a negative 32 minus 3, same signs add, keep the sign, that's negative 35. Okay, so in summary, we can commute numbers when we're adding or multiplying. So again, a plus b equals b plus a times b equals b times a. These numbers just represent real numbers. Associativity means that we can regroup. So if I add two numbers first, it's the same as adding the other two first. I can regroup numbers if I need to. And the same goes for multiplication. Okay, and then distributing is basically if you have a sum, and you have a number multiplying against that sum, you can distribute it. Identity means that, it says addition, the identity for addition is 0. Any number plus 0 becomes itself. And multiplication, any number times 1 is equal to itself. And then inverse property, so for addition, the additive inverse is the opposite of the number. And then for multiplication, the multiplicative inverse is the reciprocal of a number. Okay, they get us back to the identity. Properties of 0, any number times 0 is equal to 0. Any number that 0 divided by any number is equal to 0. But any number divided by 0 is considered undefined. So we do not, this is a big mathematical no-no. We cannot divide by 0. Okay, so that's it for section 1.5. Here's your homework. You can do odds or every other odd depending on your schedule. Okay, good luck, and I will see you on the next video.